Hello everybody, and welcome to page 110 of the workbook. In this video we're going to work through example 2. Let's take a minute just to read this together. So suppose that f of x is given by the graph below and to the left. That would be the one over here. And again, we're defining a new function a of x to be the integral from -1 to x of f of t dt. We're going to see if we can plot part of the function a of x and notice the same sort of relationship that we've been noticing in previous examples here. Okay, and they start us off with that very question. What should the relationship be between these two functions, a of x and f of x? Well, that comes down to the second fundamental theorem of calculus, which tells us when we take the derivative of an integral, we should get back to the function inside, essentially. Okay, so we could say it this way. So by the second fundamental theorem of calculus, we know that when we take the derivative of that a of x, we're taking the derivative of the integral that defines it. And we're going to get that cancellation process. We should come back to the function that's on the inside, just f. Okay, so we're really saying then that little f is the derivative of capital A. That's the relationship that we should have here. Okay, now what about part B? Well, here they're asking us to actually calculate some values of the function a. Okay, so we're going to do that and make a big table of those values and then see if we can roughly sketch the graph of this function a of x, see what we can notice here. All right, so let me scroll down a little bit. Space might be a little bit tight here, so I'm going to try to conserve space by writing small if I can. Let's start with the first number in our table, -1. Okay, so we'd like to take -1 and substitute it in for x. So first question we'd have to ask is, what does that mean when we write a of -1? Well, the definition of our function is up here, so let's scroll back up to it. Okay, so to calculate a of -1, we need to take -1 and plug it in for our x. So we're going to get an integral that looks like -1 to 1 of f of t dt. Okay, sorry for the scrolling up and down, but it would be good to be able to see our function. Okay, oh, and actually, I'm sorry, I wrote that down wrong. So we're plugging in -1, so that upper limit should be -1. Okay, because remember, back to our definition again, it's x that's up there. So if we plug in -1, that should be our upper limit. So what it comes down to then is, what should we get if we take the integral from -1 to -1 of f of t dt? Well, we're starting and stopping at -1, so there's no area under our curve on that interval, and we should just get 0. So that's our very first point. Okay, and we continue. So the next value of x that we're interested in is x equals 0. Okay, so if we take x equals 0 and substitute it in, we are integrating from -1 to x, which is now 0. And we're asking the question, how much area would be under our curve between -1 and 0? Okay, well, going back to the top of the page, notice that our curve is right on the x-axis between -1 and 0, so there's no area between the graph and the curve. That means we're still going to get 0 for that second point. Okay, and our next x value to plug in is 1. So now let's see, we are integrating, or we're plugging in 1, so now we're integrating -1 to 1 of f of t dt. So that's going to take the 0 that we already got, and it's going to add a little bit of area. Let me make that a little bit bigger. There we go. So between 0 and 1, we're talking about a triangle of area. Let me try that again. Okay, so we need to know what the area of that triangle is that we're adding in. And we can get that by just noticing what the base and the height of the triangle is. Okay, so how wide is it? Well, we're going from 0 to 1, so we've got a base of 1 and a height of 2 on this scale. So if we use that formula for the area of a triangle, we could think of this as being, okay, let's shade that area in, 1/2 times the base times the height. Do that calculation and we get 1. Okay, so we're going to get 1 for the output at 1. All right, let's see if we can sneak in one more value here. So a of 2 would be the integral from -1 to 2 of f of t dt. And so to get that, we're going to start with the 1 that we already had at the previous step, and then kind of think about what additional area we introduce. Okay, so between 1 and 2, okay, that's between here and here, kind of looking back at the top of the page, notice that there's a triangle of area above the x-axis, but then another triangle below. And notice that those two triangles have exactly the same area. And so because one of them's above and the other one's below, we're going to be adding the area above and subtracting the same area below. So the net result is to add 0. So we actually get 1 again for a of 2. All right, and we're going to continue until we get to the end of our table here. Okay, so we're going to have to do a little bit of scrolling up and down probably. Let's look at a of 3. So now we're integrating from -1 to 3. So we're going to get the 1 that we got at the previous step. And then back up to our picture, we need to look what's happening between 2 and 3. And notice that there's a square that has area 1 and a triangle that has area 1/2. Those two areas are below the x-axis, so we're subtracting those. So we end up subtracting -1.5. So 1 minus 1.5 gives us a -0.5. That appears to be our value, okay, at 3. Okay, a of 4. Well, this time we're starting with -0.5 and back to our picture. So between 3 and 4, let's see, we've got another triangle. That has an area of 1/2, but it's below the x-axis, so it's going to get subtracted. So we're going to subtract an additional 0.5 and get -1 altogether. That's our value at 4. Okay, and if you want, you could maybe stop the video at this point and see if you can fill in the rest of the table yourself, okay, and then come back and we'll see if we agree. Okay, so hopefully you maybe had a chance to try the 5, 6, and the 7. Let's fill those in together and see if we agree on the answers. So a of 5, let's see, we're integrating from -1 to 5. So we're starting from the -1 that we had at the previous stage, and then we need to look at our graph. And let's see, between 4 and 5, we're back above the x-axis. We've got a triangle of area 1/2, so we're going to add that. So -1 plus 0.5 is -0.5. That appears to be our value at 5. 2 more to go. Okay, so a of 6. We are going to have the -0.5 that we had before. And then let's see what the picture tells us. So we are adding 1 square of area and then another 1/2 for a triangle. So it looks like since those two are above, we're going to add an additional 1.5. So we get -0.5 plus 1.5. That should work out to be a +1. And finally, a of 7. We're going to take the 1 that we had before, look at our graph, and see how much additional area we add in. Okay, so let's see, between 6 and 7, looks like we've got one big rectangle that has a height of 2 and a width of 1. That's going to have an area of 2. And 1 plus 2 will give us 3, and that appears to be the last number in our table. Okay, so that was quite a bit of work, but I think we have a table of values for a of x now. And they asked us to also sketch a rough graph of a of x. So let's do that by actually plotting these points. Okay, so let's see if we can maybe scroll up and see the picture in the table at the same time. So one by one, we're just going to plot all of the points in the table. So starting with -1, 0, that will put us here. Okay, and then 0, 0, and we just keep going. And let's see, 1, 1, 2, 1, 3 and -0.5, 4 and -1, 5 and -0.5, okay, 6 and 1, and then finally 7 and 3. Okay, and so I'm going to leave it to you to actually think about how we might connect those dots in a meaningful way. Okay, so how do you think that the entire graph of a of x might look? Okay, and the continuation of this example in the next video, we'll go through that in more detail and really try to come up with an accurate idea of what a of x looks like, but I'd like you to try this first. Try connecting the dots in a way that you think would make sense for a of x.